During this film, you'll need to take down readings from the screen. This apparatus is carrying out an acid-base titration. The reaction's taking place in a beaker protected by a heat-insulating shield. Standard base is running in from a burette. The burette's been filled from this container with 1 molar sodium hydroxide solution. This is forced out of the burette along the tube to the reaction vessel by a piston which travels very slowly upwards. The movement of the piston, which is driven by an electric motor, is connected by a mechanical linkage to a paper trace recorder. The pen is registering the temperature in the titration vessel as the base solution is forced slowly over into the acid. The outward movement of the paper is linked with the volume of liquid pushed over from the burette by the piston. After the end point, there's no more heat of reaction to warm up the liquid in the titration vessel, and we get a kink in the curve traced by the recorder. We now stop the machine and take out the paper trace. The curve's rather faint, but there is a distinct kink in it corresponding to the end point. We were titrating the sodium hydroxide solution against hydrochloric acid. We construct 2 straight lines along the 2 portions of the trace. Where they intersect gives us the end point, the volume of base solution required. This can be read off against a horizontal scale. You don't need to take a reading. This was simply a demonstration run. If we take away the shield which protected the reaction vessel from outside temperature changes, you can see the jet of the burette on the left and the thermistor which senses temperature. This has a very sensitive tip whose electrical resistance falls as its temperature is increased. The thermistor is linked to the recorder. It's very sensitive, and even the warm air rising from a hand placed underneath affects it so that the resistance change is registered and the stylus on the recorder moves over to the left. Take the hand away, and the stylus starts to move back. Let's do it again. We're now going to refill the burette with the 1 molar sodium hydroxide solution for an actual experiment. Write that down. 1 molar sodium hydroxide. Down comes the piston, drawing in the base solution. We're going to titrate the base against phosphoric acid. Write that down, phosphoric acid. And we're using a 10 cc sample. 10 cc's, write that down. A 10 cc sample of phosphoric acid to be titrated against 1 molar sodium hydroxide solution. We put in a magnetic stirrer and replace the insulating shield. Then we switch on the motor for the magnetic stirrer underneath. Now we adjust the burette tap so that it will deliver the base solution to the acid in the beaker, and we're ready to start. Here we go. The piston moves slowly upwards and the base solution is forced slowly over into the phosphoric acid. The stylus records the rise in temperature as acid and base react. After a minute or so, we're getting near the end of the reaction, when the decreased movement of the stylus will show that continued addition of base solution produces smaller increases in temperature. We stop the run and look at the graph. It's faint, but there are 3 distinct kinks. One there, second one a little bit higher up there, and one here. Now these correspond to 3 endpoints. There, and there's the third one. Now we've drawn in the construction lines to show exactly where the 3 endpoints come, and you must write them down. The first is at 0.76 cc. 0.76 cc, write it down. The second one looks like, 1.38 or 1.39, you estimate it. Let's say 1.38 cc's. And the third one, 2.08. Write them all down. Now for a different reaction. Note this new reagent, 3.18 molar ammonia solution. Write it down, 3.18 molar ammonia solution. That will be in the burette, and we shall run it into this, 0.1 molar silver 1 nitrate solution. 0.1 m silver nitrate, write that down. And we shall use 5 cc portions of the silver nitrate. We put in the stirrer again. And this time, we won't use the shield so that we can watch what happens, but we will put an insulating mat underneath. Start the stirrer and start the run. Straight away, the solution goes dark and cloudy. It gets darker as the reaction proceeds. The recorder traces the rise in temperature. And soon, the solution is very dark. We go on running in ammonia solution until something else has happened. The precipitate has redissolved and the solution's quite clear again. Now we stop the run. We take away the burette assembly which held the ammonia solution, and in its place a new assembly containing a different reagent. 3 molar potassium cyanide solution, write that down. Titration continued using 3 molar potassium cyanide solution. Now there's the cleared solution from the ammonia titration. We start the cyanide run. The liquid goes cloudy again, a white precipitate this time. But after a while, it starts to clear once again. Until all the precipitate has redissolved. Now let's look at the whole trace. The first kink corresponds to the final clearing of the silver 1 solution when enough ammonia has been run in, there. A second kink corresponds to the formation of the white precipitate when cyanide was added, and a final kink when enough cyanide has been added to make the solution clear again. Now write down the 3 endpoints. Here's the first. We make it 0.32 cc's of the ammonia solution added. You estimate it and write it down. Now we move the scale along to put it 0 alongside the point when we started to add the potassium cyanide. Write this endpoint down, the point at which precipitation was complete. cc's of 3 molar potassium cyanide solution added. And the point at which the liquid had cleared again. Write down this endpoint in cc's of potassium cyanide solution added. Now another run. This time we're taking 5 cc's of 0.1 molar zinc 2 sulfate. Write that down. 5 cc's of 0.1 molar zinc sulfate solution. we're going to add the same 3 molar potassium cyanide solution. We switch on, and the piston drives over cyanide solution to react with the zinc sulfate. We get a white precipitate again. As always, the coupling links the movement of the paper with the delivery of the solution from the burette. After some little time, the solution starts to clear again. The stylus goes on registering the temperature changes in the reaction beaker. And now the liquid's nearly cleared. And the stylus levels off. The reaction's over. Here's the trace with the construction line drawn in. One endpoint corresponding to the complete formation of the white precipitate. A second endpoint to the point when the solution went clear again. Estimate them both and write them down. cc's of 3 molar potassium cyanide added. Now another run. 0.1 molar nickel 2 sulfate solution. Write that down. 5 cc's of 0.1 molar nickel sulfate. Again, we're running in 3 molar potassium cyanide solution. The green solution starts to cloud as the cyanide goes in. Now the precipitate's quite thick. Later, as more cyanide solution is added, watch what happens. We end up with an amber-coloured clear solution. Two endpoints again, one corresponding to complete precipitation, the other to the point where all the precipitate had just redissolved. Estimate these and write them down. cc's of 3 molar potassium cyanide solution added. Finally, 5 cc's of this solution, 0.05 molar ammonium iron 3 sulfate, 0.05 molar ammonium iron 3 solution. The solution darkens as the cyanides run in. It's now turning orangey. And it ends up as a clear red-orange solution. The trace gives us one distinct endpoint corresponding to the formation of that last clear red-orange liquid. Write it down. cc's of potassium cyanide solution added. Now, from the notes in the experiment booklet, use your readings to investigate the reactions which we have examined.